Hi, we're live, I think.
Hello.
Hello and welcome to this session of the Civo DevOps Bootcamp. Today we'll be looking at fast feedback. So if you haven't watched the previous sessions, make sure that you check out the description in the channel. It's got the whole playlist. Today, my name is Kai. I'm a developer advocate / developer here at Civo. And today I'm joined by Steve. And Steve is going to take you through this presentation of fast feedback. And any questions that you have at any point, I will be monitoring the chat. So don't be afraid to ask in the chat. I will be bringing all those questions to Steve, and we will get you smart. So I'll hand it over to Steve.
Wonderful. Thanks a lot, Kai. Really appreciate a chance to be here. Again, like Kai had mentioned, we're talking about fast feedback today as part of our DevOps Bootcamp 2021. I'm a senior software engineer for Plex Systems, not the Plex that you might be familiar with, the Plex.tv, but we actually sell a SaaS-based manufacturing ERP system. So far less, less or more interesting depending on what company you come from. I call myself a DevOps practitioner. Throughout my career, I've come from a variety of SRE and DevOps roles. I actually came up from the system administration standpoint. So I'm a very much old school Unix sysadmin that has morphed my skill set to have more of a DevOps and development style focus. But let us chat about our journey so far. You've learned about kind of the core concept of what DevOps is. We walk through what Docker can do and how you can use Docker to bundle your applications in a container. Then we went through kind of the DevOps tool chain, if for lack of a better term. So you learned how to take that, how to build and test your software, a variety of ways to release and deploy that software, and also how to operate and monitor it once it's in production. As part of fast feedback, what I thought is we would focus on some of that DevOps tool chain and where we can inject, how we can enable fast feedback. You probably noticed in several of the sessions so far, fast feedback is a common feature for the progress throughout all the build chain style. As Kai had mentioned, there's some assumptions that some of the basics around Docker and Kubernetes. Although even if you don't, feel free to follow along. But yeah, please do check the previous sessions in the DevOps Bootcamp here at Civo. So specifically, what we're going to look at is fast feedback from a couple of areas within the DevOps tool chain. So we're going to look at fast feedback from the developer's perspective, right? From a development standpoint, how do I make sure I can quickly iterate over my changes and then I see the responses to code updates that I've made? We're then going to look at fast feedback from a release and deployment process. Once I have a piece of code ready, or I think it's ready, how do I enable my peers, my programming peers, and my business partners to be able to review that code easily? And then we're going to talk about operation monitoring. Excellent job in the Civo bootcamp session there. So I'm going to concentrate on rollbacks. So if a deployment is made to production and all of a sudden there's a realization that we need to pull that back to a previous version, how can we enable that? Just as a notice, so in my mind, there's been a lot of talk. DevOps isn't necessarily about the tooling, right? It's a culture and a fit. In my mind, though, it's hard sometimes to take a lot of the DevOps ideals and they don't really solidify for me unless I see an example. So as part of this feedback, we're actually going to dive into specific examples. There's actually going to be a repo. It's going to be code and configurations you can actually look at and you can run yourself if you wish. But I also want to emphasize that this isn't the only way. I think every DevOps tool chain is different. It depends on your specific programming language, your environment, your company, your developer and operations skill set. So there's a lot of opportunity there. You may pick different tooling. So this is just a example so that you guys see fast feedback in a very concrete way. So I need an example app, right? And I don't want to necessarily develop one from scratch. So what I decided to do is use a example microservice application that GitHub has actually produced called the Online Boutique. They've actually had this, it's established 2015. I think that's as long as the repo itself has existed. I have forked that. It's kind of a hard fork. So because I've made, I shouldn't say a significant amount of changes, but enough changes that I doubt, I mean, it'd be nice if I could get Google to import my changes that tell you how to use the Online Boutique in a Civo infrastructure. I kind of doubt they will. So I am maintaining this. But it's a nice reference framework. It gives us a code base that we can begin looking at examples, and it avoids having to develop something from scratch myself, which doesn't make a lot of sense in this example. Now, this is an actual microservice application. So you look at this diagram, you're like, oh my gosh, what? This is way too complex. In reality, it is complex, but a lot of code tends to be this way, even in a monolithic app, which is kind of the name of if you just develop one single program, right? So that's generally called a monolithic app. In a microservice, what I do is I take my functions and my code separation. I actually separate them into completely separate instances that are running. What I like about the Google microservice architecture is that it actually, a lot of these are written in a variety of languages that are common in the microservice realm. So within this, like the front end itself is written in Golang, but other things like I'm pretty sure the recommendation service is in Python. There's a C# application, there's Java applications. But what's nice is that from your development standpoint, if you need an example of a microservice within, say, Node, I can find the Node application within here. And if you go to the repo, oops.
While you're pulling that up, Steve, I'm just I've highlighted a question here. Is this technology for college students or for experts? And I think the thing is, like, that's why I wanted to highlight it when you pulled up that big list of things. Is it looks possibly intimidating, right? You know, there's a lot of stuff going on there, but each of those, if you look at them individually, is not a massively complex piece of sort of programming or engineering. So like the email service in the top left there, for example, I mean, that's a thing that will physically send an email, right? And whatever language is written in, you know, obviously if you would need to understand that language, but like it does one thing. It does that one thing really well. And that's the idea with this microservice thing, is like you separate all of these pieces out, which means that you can then, you know, and then we're going to go into this, I'm sure, about the feedback, is the moment one of those doesn't work, you'll know, you know?
Yes, that's a good point. Yeah, it's it does look complex, but you're right, Kai, that it actually kind of harkens back to the old Unix philosophy of do one thing and do one thing well. Even though, you know, microservice, of course, is 20, 30 years removed from that. But it is a similar thing that all of these, it looks complicated, but if I look at, you know, like you said, the email service, it just does email. That's all it's in charge of. The shipping service, all it's in charge of is looking up shipping rates. So it's, I think Amazon actually has a policy of, they like their development teams, I think they call it like the 2 pizza rule, where like all the development teams, they should be no larger than what it takes for 2 pizzas to feed for a lunch.
Yeah,
it's kind
exactly.
of a funny,
yeah, because obviously you can talk about the size of the pizza as well, but like, yeah, the idea is that each individual sort of component should be able to be small enough, whether it's a team or a piece of software, that it can be grasped by like a smaller group.
Yeah, and you could, if you needed to swap out any of these services, you could rewrite them. I should say it'd be easy, but it'd be relatively easy because the problem domain is specific to just this service. And there are whole books about how you should take a problem domain and split it correctly in a microservice framework. And a lot of times you won't know until you get in production. I've been in instances where we had too much separation, so there was a decision to begin consolidating services. You notice like this checkout service pulls both from email, payment, and shipping, right? Maybe at some point as I'm refactoring, I realize that's too much separation. It's too much code maintenance. So I've decided to consolidate that back into kind of a bigger microservice. But such problem domains, it's hard until you get, you get something out in production, you begin seeing how it's worked to determine where those separation boundaries are. So it's a little more of an art than a science in many ways. But yeah. So the original question was, is this appropriate for college or professionals? I think was the question, right, Kai?
Yeah, and I guess we got sidetracked a little bit about you showing the repo that all of this sits in. So sorry for sidetracking you.
Not a problem. And actually, I'm glad you brought that up. So this is the repo that URL goes to, the SS Miller 25 Cloud Native Apps. Actually, I could probably put that in chat, couldn't I? So see if that works.
Yeah.
Perfect.
I think it's also in the video description.
Oh, excellent.
Yeah.
And actually, if you go down here, so I put my own comments in here. So the items that make this Civo specific. But then a lot of this is from the README of the original Google demo, there's a link here if anyone is interested. And if you scroll down long enough, there's that diagram I have and a list of all the microservices and what they're written in. So Python, Go, there's Java, Node.js, so C#. So I think a good selection of the modern languages that exist today. Not all of them, but these are the ones I've come across in my professional experience. So I think it's a good layout. And maybe I should emphasize too, from that professional standpoint, would you ever design a real application with this many languages? It's probably doubtful, right? Most companies, their development teams are strong in Java or strong in C# or strong in Go. So most of your microservices would be written in a single language. But given that, you do have the option, Python has a lot of machine learning libraries. So you might decide like, you know what, for my recommendation service, Python is a better language for that domain. So I'm going to write that microservice in Python. So it does give you, microservice architecture gives you that flexibility to pick the language that's best for the problem domain. But again, very much a business problem to tackle of what your existing expertise is and what languages your development team and your company are comfortable with.
And just before we jump onto the next thing, there's another question. Can a person having good knowledge of Java, can they contribute? And the answer is absolutely. And I think the important thing is also that it's not just about you knowing necessarily about Java. Like there are things that Java does really well. But if you know Java well, then that means that you know strongly typed languages. So you would be able to go very easily into, say, Golang, maybe not so easily, but like the concepts will remain the same. So you should choose your language based on the problem domain. But if you know a language well, you will know the fundamental concepts that go into programming. So.
Oh, perfect. Yeah. And like you said, Kai, I mean, there's a Java example right here. So if you wanted to pull up the ad service application, there's actually Java source code here. And actually what's nice about this repo, actually, I'm going to go a little bit off script and go into that ad service. So you have Gradle here. And actually, this is a nice example of how you would Dockerize a Java application. So I could look here for an example, maybe not, at least as a starting profile for what I might do to take a Java application and containerize it even. And if I dig into this repo, there would be the manifest for deploying this out of Kubernetes structure. So again, a reason I picked this is hopefully you could find the language, if you're a C# person, if you know more C#, you can look at the cart service. But you could pick the service that's the language that's comfortable for you and see how it would be implemented in a microarchitecture fashion, or at least an example of such. So excellent questions. Any other
Just
guy, or
keep
are
it
we
coming.
good?
Yeah, no, I think for now, definitely, keep plowing on.
All right. All right, so we're going to go. So there was 3 components I was going to concentrate. Will be the build and test experience. So the first thing I'd like to emphasize. 1 minute. I should read my own notes before I begin plowing ahead too far.
It's all good.
But the build and test experience, a lot of that. So this is only on the local developer workstation that I'm, well, for the most part, developer experience. But starting from the workstation and starting from, okay, I'm a developer and I want to begin working with this code base quickly. The first thing I'd like to emphasize is some documentation. I mean, a lot of people like to claim that there's self-documenting code. I can just look at the code and figure out what's going on. But I always like to make sure that my repos, either if it's in a mono repo or multiple repositories, the README file has enough of a quick start that I could jump on and determine what I need to get started, the tools and what needs to be installed, and then just the basic commands to get everything up and running. In this repo is actually part of the process is building a Civo repository. Now, so it's kind of infrastructure as code. I will put a disclaimer that there are better ways to do that if you're managing production infrastructure. My goal here was to at least provide something that'd be fairly easy to start if you were just getting, you just wanted to kind of dive in and you didn't want to say get Terraform running, or Crossplane or some more of the more sophisticated ways to deploy infrastructure. But I would emphasize also, like, once you develop that documentation, be completely open, especially to your newer developers. And actually all of you that are listening to this, as you're looking through this repo, you might notice big gaps in my documentation because this is designed from my perspective. I include what I think is needed, but I might be missing something. So feel free to raise issues on this repo. Feel free to request PRs against this repo if you find code changes that need to be made. I'm certainly open to that. All right, so we're going to go in and actually do a live demo. A little bit scary here, but
fingers crossed.
So we got to so we're going to make the scenario that we got a request from marketing to enable free shipping, and is in this little like store app that we have. So I'm a new developer. I'm using VS Code here, which is I think is a great idea. I tend to use VI a lot still, so I really the text editor development environment of your choice doesn't make a lot of difference. But I've already cloned the cloud native repository down, and I'm going to go, and as a new developer, it's like, well, I noticed on the front page, so I'm going to actually on the front page of the app, there's a notice about shipping. So it's like, you know what? I know that's in my front end service here in the source code. So I'm going to go dig around and I'll find header.html. And if I get here, free shipping with $75 purchase. Well, I want to free shipping with all purchases. Excellent. So I'll save that. Actually, what I'm going to do, I didn't behave myself. I'm going to create a branch. So this is, kind of getting to coding, but don't worry too much. A lot of tutorials about how to use VS Code and pull down repositories and, build branches. But we'll just call it shipping change for lack of a better term. So here's my change. Comment, upload. Actually, I'm not even going to upload it yet. So I've made the change. I've committed it because I have my local history. So I want to be careful not to go too crazy. But then if you look, so if I were a new developer, I'd probably be following a quick start here in the repo. And you notice here, I've already done the Civo makeup. So my environments are up, but I have a make file, and make files are kind of an older technology, but they've been popular in Golang and a few other languages, but they automate the building of software. So instead of writing, 5 or 10 commands to compile your source code and bundle it, you put it in a make file that automates a lot of that. And if we look at this make file here, I actually bundled all the things to build out a development environment. So I'm going to do make dev. And this is going to run, it's a tool called Scaffold, which we use for our pipeline in this example. But this would be all the commands that would be required to take your software and bundle it. Now, in this example, I'm actually, as part of this theoretical development tool chain, I'm actually deploying my dev environment to a Civo cluster. It's kind of interesting. I've seen instances where you could deploy this locally, right? Nothing stops you from pointing this to a kind of cluster, that you're running locally, or another Kubernetes cluster. So one might ask the question, why would I spend money essentially to allow my developers to deploy to Civo? One thing, especially with microservice architecture and DevOps overall, is you'd like to try to keep your environments aligned as closely as possible. I don't want to get in a situation where I only see a bug in production because my development or my local dev environment is completely different from what production is running. It's kind of a central use case for Docker, right? That's the reason I'm bundling all this software in a single package, is so that I don't have to worry about that difference between local, between dev, between prod. So I'm kind of taking that one step further and saying, even for development environments, it's not a bad idea to let to give your developers access to a Kubernetes cluster that looks very similar to how production or your development environments are running. So
yeah, so it's almost like it's one step sort of further down to more production-like environments from running a Docker container. So not only are you shipping all the dependencies and all the code and everything else, you're also almost like putting it in an environment that matches the real world, because it is the real world.
Exactly. Yeah, and like Scaffold is a tool that lets you take Kubernetes manifests and deploy them kind of in a systematic way. There are a lot of other tools that do similar things. So this isn't, again, as I emphasize a bit, this isn't the only way to do it. There are a lot of other ways. There might be even a lot of better ways depending on your situation. So this is just, again, an example to kind of solidify what this would look like. Okay, so I have my development environment done. This error comes up every now and then, so I haven't debugged it, but I assure you it is okay.
I was going to ask whether it's actually deployed correctly, because you did get that warning.
It should be. It's something I noticed only last night, so I've not had a time to debug it, but I've not noticed an issue, but we will see. So in my example for the demo, because it's a development environment, this isn't exposed to anybody to the world. It's just a Kubernetes application sitting in its own little namespace. So what I'm going to do is and this is in the makefile instructions, I'm going to port forward into that environment. So taking a port from my local machine and opening it up so that I can actually see it. All right, and so port 8080 now is open. And we'll see if this works. Ta-da! So this is the code I just wrote, and this is that free shipping with all purchases. So not a crazy amount of change, but there we go. And what I would do is now I can iterate pretty quickly, right? I can make changes, do that customize, apply. It took a minute or two because it does a lot of steps and some verification steps to make sure my code isn't completely blowing up. So,
and again, sort of those steps we sort of kind of touched on in the test episode of the bootcamp, where you have a lot of automated steps to essentially determine that everything works, and you can't completely remove human error, but you can make sure that you get a repeatable set of steps every time, which is what you saw in the sort of terminal output, where it's pulling things and it's layering the Docker container layers on top of each other and doing all of that. And that's kind of one of those things that allows you to make sure that what you're seeing is a real change and a real feedback, since we're talking about fast feedback, because you've already determined programmatically that everything else should be as it should be.
Yeah, that's a great point, Kai. Like getting this automated to a way so that if there is issues or there are issues, you'll see them quicker, right? You'll see this build fail. Fail more than just the scaffold run tail logs. All right. So now that we're a developer, we got our change deployed. I've tested it locally. I think it's great. Now I need to know, and I need to get it approved. I should say approved. I shouldn't say need to get approved, but I should get it approved, right? In most development shops, a single developer can't just push to production right away without at least vetting that their code looks good. So I'm going to actually push this branch out to my Git repository. And GitHub being as great as it is, shows me that I have new changes now. But what I'm going to do, so just to kind of put a little bit of a description of what I'm going to do, I'm going to review now the release deploy cycle, and I want to concentrate on pull-based review environments. So a way that you can allow your peers and your business peers to look at your code quickly and determine if it is correct or not. So as part of that, I have a build pipeline, which we talked about a little bit before, that will essentially deploy an environment that's very similar to the one I just deployed for myself, but will be exposed so that anyone in the company could potentially. And of course, now the live demo has failed. Why is that not allowing me to?
And this is the danger every time you do live coding.
Yes.
One of those things that you weren't expecting.
I'm going to quickly try to merge master in. I have a merge conflict, so let me accept.
Yeah, I mean, but this is also very.
It doesn't really matter.
Yeah. So you've already done it once and just with a slightly different wording. But this
yes, and actually,
yeah. Go ahead.
I was going to say a lot of this is because I have this demo set up for other parts of the presentation, so it's kind of broken in production right now. I should say broken, but it's set up in a specific way in production, and I tried to back out. Okay, cool. So what I did is I fixed that merge conflict quickly. I pushed it back out to my repository. Now if I go back and I do a pull request. So basically what GitHub was telling me is that you can do this code, but I can't merge it into the main code base. There's a conflict. So I resolved the conflict on the fly. So cool shipping changes. So, you'd write out your pull request description. A lot of companies, this has kind of a very basic template. A lot of times there'll be checkboxes, so the developer has to say, you know what, I went through all the CI pipelines. I did full end-to-end testing. I had check off in the various departments. So I'm going to create my pull request. And then hopefully, so in GitHub, a pull request is a request that I have code that I want to commit into the repository. Here are my changes. And if I look here, I'm surprised I don't see any files changing.
Is that because
I think that's not a problem. Normally you would see file changes here, but
because you pulled in
I
the
think it's
master,
because,
you pulled in the
yeah, and I
latest changes
thought,
from the main branch, yeah.
yes, I thought I'd done it in a way. I'm just going to peek at one that I know is a little better. So these are older pull changes. These are merged in already. But normally here in the file changes, you'll see, this is probably what you should have seen, right? Like it was 75, now it's all purchases. So pretend you're seeing that. The presentation has the good screenshots. So, but this shouldn't affect this pipeline actually, because so this pipeline, checks. So I'm going to go here and we're going to watch this live. This takes, this pipeline itself takes about 13 minutes to run. It's a little long. And I'm going to go look at the code that defines that. So build pipeline, I'm telling GitHub when I have new pull requests or when something happens, I want you to run a series of steps. So in this GitHub workflow CIPR, and this is highly dependent. This is for GitHub Actions, but if you're running Jenkins, it'll be completely different. It's a similar concept, just a different file. Circle CI, Tecton, all of them are CICD platforms that you configure to tell it like, actually, if I look, GitHub Actions is nice because it's relatively simple and it's built into GitHub. So anybody with a repository can play or can work with this. And there's lots of examples. So this one is any pull request against my master branch. So anybody that's trying to merge code into master, it goes through these various steps. I check it out. I set up .NET. And actually the first thing it does is these code tests. So there's a whole series of automated unit tests that are run as part of the build pipeline. This runs every time, but it's nice if I had changed something in the C# that would have failed a unit test and I didn't catch it. This would have stopped the P, or this would have flag red on the PR, and I would know that I need to adjust it. So as part of the PR, I'm doing some automated tests. And then the deployment test is actually the process that will deploy this to a mini environment so that others can look at it right away. So I'm going to go back to one of those older PRs. This guy's going to take a while, so I didn't want to necessarily. So I'm going to go to one of my other shipping changes. And you'll notice, big rush for marketing. I have my description. But then at the end of this, that GitHub pipeline will output this little section of code. My PR has been staged to this address. So I'm going to go open that up. And this should be just like that development environment I saw, only notice it's a public IP address that you can hit. That actually is live, but this is on a cluster with nothing else. So I appreciate if no one broke it, although
So
that
this
might make the presentation a bit interesting.
Your pipeline will deploy on a successful merge to this thing, and it will show on the results of the pull request this public IP address.
Kind of. So actually, the first pipeline, the CIPR pipeline will actually, this runs anytime you create a PR request. There is another one that does run on merge though, so we will cover that. But so this theoretically would be a development environment. So you'd never share this address to anybody but other developers. But what's nice is that, oh, go ahead.
No, I was just going to say, like you when you said earlier that this request has come in from marketing and they would like it, this is a physical website that you could then pass to your team and go like, hey, does this look all right to you? Because this is exactly how it would look like in the real world. And they could access it on their phone if they were at the cafe or whatever, and they can then ping back you an email and go like, yep, cool, that's cool, looks exactly how I wanted it.
Exactly. And it was mentioned in our build and deploy Civo bootcamp, I'm fairly certain. But I've been in environments that had this set up, and it's amazing because not only can, like you said, Kai, like a developer can see it, but also I can show this to marketing. I can show this to sales. And you don't need to know how GitHub works, right? I just have to give them this URL and say, hey, I made this changes. Does this look good to you?
Yeah, exactly. And then if you think back to the sort of DevOps infinity symbol, right? That's the sort of feedback that you're then passing to plan the next stage, and like it's all a beautiful merry-go-round.
Yes, exactly. And then I'm going to see if my PR is done yet. Nope, it's still, that little yellow means it's still running. But like I said, I'm not surprised because this will take, how long? It's 4 minutes. So we have another 5 minutes to go. I'm not going to wait.
And is that particular pipeline that slow? I'm not going to say it's slow, but like, does it take that long because of the number of different microservices running on different code bases and different languages that it has to build?
This one's a little slow. I'm using free GitHub runners, they're called. So, I'm not paying GitHub. So I think it's a little bit slow itself. If I were to deploy that on my own hardware or pay GitHub money, it would be faster. But also as part of the pipeline, there's a lot of testing, automated testing. So that takes a bit of a while. I'll go through. So this deploys, waits for all the pods to come up. But then trying to look for, the load. So there's, if you remember the original microservice app actually had a load generation pod. As part of this build pipeline, it actually kills that pod off and then waits for it to have, I believe, 50 successful requests, and it makes sure there's no errors as part of that. So as part of my pipeline, it's doing a very basic smoke test to make sure that the code I'm proposing doesn't break the site so poorly that the load gen breaks.
Yeah. So basically, it's testing that, yep, the page still loads, and it needs to get 50 of those in a row in order to consider itself running.
Exactly. And so that also contributes to why this takes a bit longer. And as a company, you might have to decide, is that worth the delay? Now, in some ways, I've seen deployment processes take weeks. So the fact that this takes only 10 minutes or 20, because when I push this to prod, it'll be another 10 minutes because it goes through yet again all the tests just to make sure before production gets hit. But you can decide as a company, I need faster velocity. So I need to either look at reducing the number of tests. I might have to look at what machines are deployed as part of my build pipeline so that they work faster. There are a lot of methods to make this process quicker. So fast feedback, I should say, is in the eye of the beholder in some ways. Depends on your definition of fast. But
yeah, exactly.
There are definitely different strategies you might take.
And fast is also relative, right? So if the company has previously deployed once a month or once every 3 months, and now you can deploy at will, but it takes 20 minutes, well, that's an incredible improvement.
Exactly. And you can always, you can get it out there, you can take a look at it and determine, do I need to make this faster? Are there other improvements that I can make to the entire deployment process? So I'm going to pretend that went, it's getting close. This will be tough. So it's actually deploying the PR images, but it'll take a while to get through all the smoke tests. So what
You're not going to wait for it?
Do, I could actually. 1 minute, let me see
if
how
there's any other
long
questions from the audience, we can, we can definitely handle a question or two before.
Yeah, we have 9 minutes. I have some others. All of these are successful merges and whatnot. So if I go to this, as you can see, I can undo. Yeah. So this is what it would look like when it's done. So it does all the code tests. Here's all the deployment tests. Most CICD pipelines let you pull up the individual tests so that you can see in detail what they did. So I can look at the build and deploy PR images. I can see this took 11 minutes. So that's actually most of my time. It's not the smoke test. It's actually building the images. So if I wanted to optimize this process, I would know where to start. All these others are 2-3 seconds long. But as you can go, it's going through here. It's pulling, here's that Java container, right? It's pulling OpenJDK, the base layer of that, and it's going through, it's copying the source files, it's running Gradle, very much a Java-based build process. And actually, as you can see, it's kind of running sequentially. So that definitely would be an opportunity that I might be able to spin this off into several threads, and that might get myself the time savings.
Obviously, at the cost of you needing to provision more hardware for running that.
So when that's done, so let's say that completed, right? You saw the green, everything was good. As part of my PR, once all these turn green, I would probably click this merge pull request. So that would take that request that I said to make code and merge it into the main or master branch. When that happens, another CI/CD pipeline kicks off that actually deploys my code to production. And again, that would take another 10 minutes, but to avoid that, I'm going to go back to the actions, which is all my CI/CD pipeline changes. And actually, this is one of those pull requests, so it's going into master. Did it 3 hours ago. And this one is actually structured very similarly to the PR test. It just, when it deploys, I'll see if I can pull up the command. It's actually running make prod from my make file, which is almost exactly the same process, only it's hitting a production cluster. And for my example, this is my production cluster, which looks the same as my dev instance because I already deployed that change out there for this demonstration. But what's nice is that all of this is part of the CI/CD pipeline. I didn't have to engage a separate team to take my code and deploy it to production. It's all part of the pipeline, all part of the approval process, which we'll see in a moment why it's very beneficial to have that all bundled in. Any questions so far?
We haven't had anything just now, but there is this one which is kind of maybe related to the earlier part when we were talking. It's like, is how do various microservices talk to each other, and how would different databases talk to each microservice if they have their own databases?
That is a very good question.
And it as Tushar says, like it was an interview question, but. So, I mean, the short answer is, well, I'll let you run with it.
I was going to say, the short answer is it depends, ...
Exactly, but I'll let you run with it.
I don't suggest that for an interview process. So there's two main ways. There's a lot of ways microservices can talk to each other. The two main ways directly, it's tough because I'm thinking of all the edge cases. So I'm going to try to put those out of the edge of my head. The main way is RESTful APIs or gRPC, or just, so this microservice app is actually based on gRPC. So it's a remote procedure call method. It's kind of a lightweight way of an application of calling a method or function in a completely separate program, but that I have enough information that it returns the data as a structure, and I can take that structure and I can consume it and leverage it. So gRPC is relatively new. It's very fast. It's a bit more complicated. REST is using HTTP technologies to hit an API, generally return JSON style data. And if you put in a certain path and use HTTP verbs, to query certain data. So that's kind of the briefest answer I can use for how microservices talk to each other. This being from Google, and Google being the creators of gRPC, they are the ones that use gRPC. The only exception is, of course, the actual browser-based traffic. That has to be, well, it doesn't have to be, but if you want users to actually use your service, HTTP is the way to go. So that in this diagram is why these are labeled HTTP. All these other arrows are gRPC. And again, the source code's right there. So if you need to see an example of how you would leverage gRPC, this repo is a great example of that. So I think the other question kind of going to this was databases. Again, it's one of those, it depends, because it really depends on your architecture. You could deploy databases in Kubernetes or NoSQL databases. You'll notice as part of this, Redis itself is deployed. It's kind of a very lightweight name value key store, although it can do some queuing and some other interesting things. You can deploy a traditional database, a MySQL or Postgres SQL database. There's some interesting oddities with running databases in Kubernetes. So be aware of, because in Kubernetes, pods can disappear and reappear at will. Not a problem if you're running any of these are stateless services. So they don't really maintain state themselves. Obviously, your database, you don't want it just being killed off randomly. So you would probably want to look at Kubernetes stateful services for a more controlled way to manage workloads that need to require state, which most databases do. In a cloud context, a lot of people will oh yeah, go ahead.
No, so I was going to say, or you can store your database outside your cluster, in as a sort of managed cloud service, or just outside your sort of containerized space.
Yeah, and that's in the workloads I've deployed, we tended to use external services from the cluster, either as traditional infrastructure, on IaaS type systems, or a lot of cloud providers provide a managed SQL service. Sometimes a little pricey, but a lot of times it provides like backup and some other niceties. So that's generally how it answered like the database questions. Excellent, though.
Yeah, if anybody has any other questions, just put them in the YouTube chat. We will get to them.
All right, let's head back to. So let us assume we deploy that to production. Everything is great. Now let's talk about the third type of fast feedback, that whole rollback on demand. So let us look at our Windows. Let's go look back to our production instance. You get a call from your support team at 3 in the morning, and they're like, so we noticed a problem in the cart. So if you go to add an antique camera and I say, add it to my cart, you'll notice this is here. Oh no, the developer who pushed out this code, they changed the header to free shipping, but they made no other changes to the application. So it's charging shipping, even though we bragged that we're not. So you, as the developer or production person on call, is like, oh no, how do I solve this? What do we do? So generally, if everything's configured as code, right, and I know my infrastructure is as code, so everything should be able to be traced back to a pull request of some sort, some change in the code. So I'm going to go look in my closed PRs. And I'll notice that the last PR submitted a few hours ago was from this SS Miller guy. It says, move the free shipping. So I open that up to try to get what happened. All right, move the free shipping. It was a big rush from marketing to get this out. And I noticed, if I look at the file changes, yeah, the only file that was changed was this front end change. Nothing else about any of the shipping services. Now I could try to go fix this, but I know this is probably a more involved process to update the shipping service and test that and review that to make sure it's behaving. So I just need to get the site up and working to how it existed before.
Because, as you said,
so in
it's
GitHub,
3 a.m.
Yes, it's 3 a.m. I just need to get this fixed, right? So I can go to bed and we can solve this
on Monday morning
in the future, or on Monday morning. Yeah. So I'm going to click the revert. So the revert button in GitHub and a lot of source repos will take that source code change and build another pull request that just undoes what that pull request did. So, it kind of templatizes everything. And if I look at what it's proposing the change, it's going to go back to the $75 purchases. So excellent. So we'll create that pull request. So this creates a brand new PR. So this is just like that second phase. So the PR is going to try to run through its continuous integration test, right? It's actually going to build a dev environment. Now, depending on how the reversion is, maybe I want to wait for that, right? Maybe I'm scared of the change. But in this change, I looked at it and it's just an HTML template change, right? I'm pretty confident it will work. So in a lot of source code repos, you can force that you can't merge until you have an approval process. In this particular repo, it's not set that way, or perhaps your operations team or whoever's on call has the ability to override that policy. So we're going to pretend it is the case. So I'm actually going to merge this without waiting for my PR or CICD pipeline to go all the way through. Generally not advised, but again, 2 a.m. in the morning, I made a judgment call that I think I'll be okay. So this got merged in. So now that undo has hit. If I look at my CICD pipelines, I'll see them from the PR, right? The reversions. So this is still going to run, and I could cancel it if I want to, but there's no harm in it. But this one is the PR that's actually going to merge into production. Now this is where that timing becomes made more critical, because we have kind of a site down. We have a 10-minute pipeline. There's nothing I did in this particular instance, but there are methods that you could run. You could perhaps tag it and it would run a different CI/CD pipeline that's stripped down of all the tests that just basically deploys to production.
Yeah.
And being that these are all Docker containers in the back end.
Sorry, I was just going to say, for example, at Civo, if we have this kind of situation, there is a method where, a change can be pushed literally straight to production, and it's only ever used in absolute emergencies. But when you need to get the site back online and you know that change is going to do it, that's what you do. You'll worry about the consequences later.
Yeah, exactly. And we had something similar with my environment. There was, even currently, we have shell scripts. It sounds kind of kludgy, but it essentially is a way to bypass all the build pipelines and be able to deploy directly to the production cluster a previous version of the application, because these are all Docker containers, right? So it's very easy to say, go back to the last version of the Docker that was built and that looked correct. So actually that might be a better strategy, but it depends on the situation, right? If this were a really complicated case, I may want to run all the CI/CD tests just to verify that I'm doing this doesn't make things worse. I'd rather, it fail the CI/CD pipeline. So it really depends on the nature of the situation, and how much tolerance I have to wait another 10 minutes in this particular example to deploy back to production. And actually, this seems to be going pretty quickly. It's still 1 minute. It's interesting. Yeah, now it's going to bug me, and I want to actually go and try to debug this slowdown. But I was hoping to time this so that we would have this reversion done by the end of our DevOps presentation, but I don't believe that will be the case.
But sort of just to go back to what the sort of theme of the presentation is, if you look on the right hand side of the GitHub runners and you see those time stamps counting down or counting up, those are, like you were saying, those are places where you can go in and go, can I optimize this? Can I find a way? So that's fast feedback in terms of deployment.
Oh, true. Then I could just look at that and I could determine, okay, here's places I could optimize. And like Kai said, this would definitely be where you think wow, I need a faster process to revert production, because we need a failsafe trigger if something goes down to quickly revert. And a lot of times, as sad as it is to say, you tend to develop those tools after a major outage that it's taken too long to revert. But that's kind of the nature of continuous improvement, right? You see where you've had gaps. You go and look, you do postmortems. Blameless postmortems are excellent. Because really, if there was a problem that took a long time to resolve, you should never blame that on an individual person, right? It's something with the process, because there should be enough fail safes in place that a single individual shouldn't be responsible for bringing down production. Ideally,
and like it's a failure of process, not of people, and it's not a failure as much as it's a learning opportunity, right? If this keeps happening, like let's say this is a situation that repeats itself, then it starts to indicate a problem. But if this is something that you learn from and mitigate for future times, and that's exactly the continuous improvement, the CI part, of I realize it's continuous integration, but like it all implies an improvement.
Exactly. And just to prove that this did work, I have a screenshot with what it will look like after that CICD pipeline is completed. But yeah, it'll revert to the original free shipping with $75 purchases, and then we're back to normal. And like I said, usually after the fact, there will be a review of how did we miss this type of change happening, and what can we do to prevent that and improve our processes going forward.
So then, yeah, no, go ahead.
Oh yeah, I was going to say I'm kind of watching that off screen, so if that comes up, I will let everyone know. But 1 minute, was off screen. Now it's still on. But I was just going to mention, so that's that URL again. Feel free to take a look at it. Feel free to try it out. There is a warning because it deploys to, I believe it deploys 2 3-node medium-sized Civo clusters. So just be aware from a budgeting standpoint. I think that's about $32 a month. So just be aware of that. I try to warn you in the make file, but I do welcome any issues or pull requests to the repo itself. Hopefully I'll be making some improvements to the build pipeline before you get a chance. This presentation itself is available on that URL, present.r15cookie.com. That actually this is all kept in code as well. So if you want to make PRs against my presentation itself, feel free to. And I'm also on the Civo community, just Steve Miller. So I'm always open to questions or whatnot. So,
and Steve is one of our ambassadors. So he's got one of those little ambassador badges next to his name. And yeah, he's if I know he's pretty much on all the channels, so I guess beginners would be the best place to tag you if somebody has a question about this presentation or like the the repositories, like if they want to ask about an issue or a pull request that they make, or any part of how it works.
Yeah, that'd be excellent. Like I said, going back to my documentation, I've been the only person who's looked at this documentation from at least, adjusting the cloud native app to Civo. So I definitely welcome any gaps that you see or improvements that can be made overall to the repository.
Cool. Well,
oh boy. Well, thanks a lot, Kai. Really appreciate it. This has been
thanks.
This has been quite
Steve,
fun.
thanks for doing this. And like Steve said, like the Civo community Slack is the place to catch, well, all of us really. The entire Civo team, myself and the rest of the team are always there when we're awake, basically. And and Steve hangs around. The other ambassadors are all super helpful. So any questions you might have about DevOps, Civo, Kubernetes, anything like that, make sure that you ask. We also have the Civo the Academy, which is at civo.com/academy, which is entirely free. So if you haven't signed up to Civo yet, you just go to civo.com and you sign up, and then you go to Academy. There's, I think, 50 less video lessons, which sort of complement this course, but more from a pure like Kubernetes perspective. So yeah, check that out. And thanks for watching, and thanks again, Steve, for doing this.
You're welcome, and thanks everyone for tuning in.
All right, bye.
Bye, everyone.